This is the second video in the series of tutorials discussing the LX7720 radiation-hardened motor driver for space. First, here's a reminder of what the LX7720 actually is. The LX7720 is a mixed-signal peripheral, which works with either an FPGA or a microcontroller to build a complete closed-loop brushless DC motor controller or a stepper motor system. The previous video provided an overview of the motor driver half bridges and discussed how the low-side and high-side MOSFET gate drivers work. This video discusses practical half-bridge driver stages using either standard gate voltage or low-gate voltage MOSFETs. The LX7720 uses 10-volt to 18-volt VGS gate drive supply for compatibility with conventional high-gate voltage NFETs. This schematic shows an example half-bridge stage using two such NFETs with typical component values. High-gate voltage NFETs are turned on hard with an 8-volt to 12-volt gate voltage and usually have a maximum allowed VGS in the 20 to 30-volt range. The diodes with dotted lines are the MOSFET's integral body diodes. The body diodes are usually rated to carry the same current as the MOSFET itself and can be used to recirculate inductive load currents during commutation. Commutation is the off time between turning one NFET off and turning the other NFET on. The 20-ohm resistors, in series with the gates, are nominal values which form an RC network together with the gate capacitance to provide turn-on and turn-off slew limiting control. The diode shown in parallel with each 20-ohm resistor is commonly used to allow slew-limiting joint NFETs to turn on, but retains fast turn-off when the diode conducts. The 20K ohm gate source resistors ensure that each NFET is off when its FET driver is high impedance. Now let's talk about using low-gate voltage NFETs, commonly called logic-level FETs. These FETs turn on hard with a much lower 2 to 5-volt gate voltage and usually have a low maximum lag VGS in the 6 to 10-volt range. The 10-volt LX7720 VGS supply minimum is therefore too high for these FETs, but that doesn't mean that they can't be used. Here's an example half-bridge stage with typical component values losing low-threshold voltage NFETs with a 6-volt maximum VGS rating. First of all, we choose a nominal VGS supply voltage of 12 volts, comfortably above the 10-volt minimum allowed, to allow for supply tolerancing. Each NFET's gate drive is limited to nominally 4.3 volts with the Zener diode. Per the LX7720's operating ratings, the limit for each NFET driver's average sink source current is 25 milliamps. So, we included a 470 ohm series resistor to limit the DC current from each NFET driver to about 16 milliamps. Here's how that is calculated. As before, a diode in power with the 470 ohm resistor ensures a fast NFET turnoff. However, turn-on is slowed down by the relatively high resistance 470 ohm gate drive resistor. We can restore fast turn-on by fitting what's known as a speed-up capacitor across the 470 ohm resistor. The capacitance value is chosen to supply the NFET's initial gate charge and speed up the NFET's initial turn-on to its Miller plateau. The balancing speed-up capacitance, CSU, supplies the NFET's gate source charge QG. Here's how that is calculated for a 12-volt VGS supply and using NFETs with a 12 nanocoulomb gate source charge. That concludes the discussion of practical motor driver half-bridge stages. In the next video, we'll discuss options for current sensing and how to implement them.